This video will focus on being able to distinguish between metals, nonmetals, and metalloids, both in terms of property and location on the table. So if you look at our modern table, we have something we call the stair step that kind of zigzags down the table right by boron and silicon and germanium, kind of right in that area. This divides the metals from the nonmetals. So majority of the table is metal. All the yellow on there is metal. Then we have our nonmetals up in that green area, so above the staircase. And right along the staircase, we have what's called metalloids. So things that both have some metallic properties to them as well as some non-metal properties to them, but they're very unique in their own way. Because the metals are such a big part of the table, a lot of the metals areas are called something different. So the middle D block are usually called the transition metals. You can see the bottom, the lanthanide and actinide metals are on the bottom. And then we'll talk about some of the other metals in a different video. So in terms of characteristics, you probably know a lot about metals already. Metals are considered good conductors, both of heat as well as electricity. Generally speaking, metals we encounter are solids at room temp, except for mercury. Mercury's melting point is such that it's a liquid at room temp. Metals are very shiny, which means they have high luster. It means they're very reflective of light. This is probably something that's new. When metals form ions, they tend to form positive ions. And then metals also are very corrosive. Nonmetals then as a group, and we don't really think about these as much because they're more varied in terms of their appearance, but nonmetals are generally non-conductive, both of electricity, and they vary in terms of their states of matter. So we have like oxygen, which is a gas at room temp, and we've got iodine, which is a solid at room temp. So our nonmetals vary in terms of, as elements, what state of matter they're in. As a group, they do not have luster. They do not reflect light. So they're usually matte in appearance. When they form ions, they tend to all form negative ions. So they are gaining electrons. And then in terms of a structure thing, nonmetals tend to come as diatomics when they're by themselves. So that idea that like oxygen comes as O2 and iodine comes as I2 when they're in their elemental form. That's something that's common across a lot of the nonmetals. Not every nonmetal does it, but a lot of them do. Metalloids then are a different group. We say they're kind of in between, but again, they have their own characteristics, like them being semiconductors. So a lot of metalloids are used in electronics because these are semiconductors. We're able to regulate the flow of electricity as well as heat. So silicon is used a lot in electronics. Metalloids, again, vary in their states of matter, similar to nonmetals. And then the rest of them are variable. So silicon is a really interesting one again. If you think about like a big massive amount of silicon, it's not going to have any luster and it's going to be kind of white to it. But if you get thin sheets of it, it actually gets metallic looking and shiny. So it depends kind of on the form of it or how much of it you have or whether you've polished it or not, whether it's shiny. It's also variable in terms of its ions and its reactivity. So the huge thing about metalloids that set them apart is the conductive aspect of it. It's something that we use in daily life. Okay, that's it. Have a nice night.